Okie dokie. Let's now move on to the second part of naming, which is with the functional group. So if you guys remember, oh, it's probably not gonna like me going so close to the mic. If you guys remember, I said there was all these little like steps that we have to do. So find longest chain with the functional group if the functional group is present. Same thing with the numbering. If functional groups are present, give it the lowest number possible. So now that we're talking functional groups, these two rules are coming into play. Let me kind of talk about function groups as well and what we need to do for naming of them and how we name each one. So be mindful, when we are trying to indicate the existence of a function group, it happens in one of two ways. Either we add it to the beginning of the name, which is known as a prefix, or we change the ending of the parent chain, which is known as a suffix. So just so that way we know, there's also the option to add functional groups as a prefix. And I'm just going to walk you guys through all of them. I'm going to have to pull up our lesson from last week and look at all the different various functional groups, just so I remember all of them, because I don't remember them off the top of my head, but I can visually tell which one's which. So we go here, we'll just go to the answer because that has the beautiful picture of all of them. Be mindful, we don't need all of them. Okay, so some things to keep in mind, and let me put this onto the sheet. We'll go back and forth. The first one that they mentioned, I'm just going to put it, no, we'll keep it all the same way. All right. So you could have a carbon double bonded to a carbon. That is your alkene. Note that the name of the function group now changes because you have an ENE ending. And so when you go to name any organic molecule that is an alkene, you will just change the suffix to ENE instead of ANE. So that's how you change the naming for an alkene. The next one you could have is a carbon with a triple bond. That is an alkyne. Again, I'm very sorry, but you can see how it's just changed from an E to an A, and again, you would be a suffix change to that. All right, let me just go back and forth from that document so I remember all of them. The next one is an alcohol. So alcohols, just so you guys are aware, when you see R like that, that just means a carbon chain. So it could be one carbon, it could be 5 carbons. It's just a placeholder to say there's a carbon chain somewhere here. Now with the alcohol, it is an OH and only an OH component. That is your alcohol, I had to spell it. All right, you have two choices in how you name alcohols. You can either do a suffix, which is OL, or you could do a prefix, and the prefix is hydroxyl. So that's your prefix. So I'm just going to put a color code. If it's in purple, that's a suffix. If it's in green, it's a prefix. We good? All right. So once you know the basic rules of naming, it's just a matter of changing the ends or changing the beginnings. Next one that you guys have to do, you don't have to do ether, you don't have to do these ones, haloalkane. So we represent that by an X. X is just referring to any halogen. So halogens are group 17 of the periodic table. So we call this a haloalkane. This only has a prefix, and the prefix is based off of the halogen. So if you have chlorine, it would be chloro. If you have bromine, it would be bromo. If you have fluorine, it would be fluoro. If you have iodine, it would be ido. Okay? So it just depends on what halogen you have. So those are your haloalkanes. I'm just going to flick back and forth. Don't worry. It will come back. I'm just trying to remember which ones you have to do. Aldehyde and ketone. Right, gotcha. Okay. Aldehyde, double bond O, H, and then an R group. So what that tells you here is that the carbonyl, which is the C double bond O, has to be at the N carbon, one of the two N carbons. This is your aldehyde. And this only changes as a suffix, and that changes to an AL suffix. The other thing I should actually note is when you need to include numbers and when you don't need to include numbers. So you need to include the carbon number that these functional groups are attached to for the alkenes, the alkynes, the alcohols, the haloalkanes. So this equals need to include carbon number of functional group. Are you okay with that so far? We'll do some examples. The aldehyde, you do not need to do that because aldehyde can only be on the N carbon, so it can only be on carbon number 1. So you don't need to do that because it's only on carbon number 1. We good? All right. If my carbonyl is not on carbon number 1 and it's C double bond O and then there's 2 R groups, each R group is representing a carbon chain. Those carbon chains do not need to be identical. So you could label this as carbon like 1 and then this one is a second chain, different chain. Doesn't matter. This is now a ketone. So it's the carbonyl not on carbon number 1. All right? The ending for this guy is going to be on, or 1, matches with this naming here. This naming matches over here, if it helps you kind of remember them. This one, you do need to mention carbon number. All right, do you guys need a second to copy that down? Moving on? Okay. Becky, you okay? Do you want this piece of paper? Okay. All right, I will scan all of this as well. Okay, so that covers ketone and aldehyde, carboxylic acids. Let me draw that guy for you. So carboxylic acid, let me just try to keep the colors that I was doing. What was I doing? Pink. All right. So C double bond O, OH, and then R group. This is our carboxylic acid. So the things to kind of keep in mind with this guy is that it has a carbonyl, C double bond O. It also has the OH. So it's kind of like the aldehyde and the alcohol had a baby. Very different properties though now, okay? But just be mindful, it's the combination. They also need to also be on the same carbon. If they're on 2 separate carbons, then you have an alcohol and an aldehyde, or an alcohol and a ketone. But when they're on the same carbon together, that's a carboxylic acid. This only gets named as a prefix, and it's oic acid. And you do not need to state carbon number for this one either, because it can only be on carbon number 1, N carbon. So that one makes it a little bit easier. All right, what else have we got? Don't have to do that one. Esters, we will hold off on doing because esters are quite complicated to name. Sorry, Esther. Just so you guys are mindful what that guy looks like, remember it's the carbonyl with the bonded oxygen and another carbon chain. So we'll hold off on esters. I'm just trying to be mindful of time. Okay, I'll try to finish it up quickly. Amides. Again, it gets a little bit complicated sometimes. I'll just give you guys the basic. This here, that's an amide, and we call this one a primary amide because this carbon here, this nitrogen here is only attached to 1 carbon. You could also get amides where the nitrogen's now attached to a carbon, like that. So you see how this nitrogen is attached to 2 carbons? That's still an amide, but now it's a secondary. And then if you have it that this nitrogen is attached to 3 other carbons, that's a tertiary. So just something to keep a heads up on, that it does change primary, secondary, and tertiary. Don't worry about naming these guys just yet, because I'll talk about it after we do our spec topic. But just as a note for the naming, it'd be mide, like that. And in this case, you don't need to specify number, because it's going to get a little bit complicated. We good? I'm tossing a lot at you, I know that. All right, amides, acid halides. Yes, so this one we are only going to do as the acid chloride, and that's C double bond OCl with an R group. I like to call them acid chlorides in my own personal preference. This one here, you'll notice it's like the carboxylic acid, but instead of the OH, you have a chlorine. And now I got to remember how to name it, and it's escaping my mind. It'll come back to me. Not too critical at this point. I'd rather get through all of it. All right, amines, very similar to amides. You have a carbon that's attached to a nitrogen. I should actually write, should be more consistent in writing R's, but that's okay. Anyway, carbon attached to nitrogen. This is an amine. You'll notice that it doesn't have the carbonyl attached to it anymore. Now, some things to keep in mind. This is a primary. If the nitrogen is attached to a second carbon, like this, like the one up here, secondary, and if it's attached to 3 carbons, think 3 carbons tertiary. I'm just pointing that out to you guys because it does influence how you name it and things, but we don't have to stress about that at this point. Be mindful the ending for this is amine, or you can have the suffix, which is amino. So you have 2 choices, suffix or prefix. This one you do need the number. This one you don't need the number. All right? I'm just mindful we have like a minute left, so I'm kind of powering through it. I think we don't have that many left. That one's done, that one's done, that one we don't do. Yep, we're done. That's all the ones that you guys need to know for this year. Cool. All right, tomorrow we will look at some of the NCEA questions so you guys can practice it. You can go ahead and get a start on it if you want. I have linked it onto Google Classroom. It is the collated questions from No Brain to Small. Just skip any esters. You guys are not ready to do esters, and you are not ready to name any of the complex amides, which I don't think they generally do. So this here's an ester. You can skip that one. All right. Cool. See you tomorrow.